In this circuit diagram, we need to find the Norton equivalent circuit with respect to terminals A and B. Our Norton equivalent circuit is this circuit that I have taken a picture of below and put it in this problem. So it needs to look like this when we are done with it. When we look at our circuit given, we can see that we have a voltage right here. So this is going to be our starting point since this is our initial voltage. We can kind of dissociate everything to the left of it from this problem, as it's not really going to have much bearing. Now we are going to use source transformation. We're using a source transformation when we look at this voltage and this resistance that accompanies it. We are going to turn this into a current, and then we are going to make our resistance in a parallel form instead of a series. First, we need to find our current. We can do this by using Ohm's law and setting current equal to voltage over resistance. We know that our voltage is 30 and our current is 15. When we do this, we're going to get that I is equal to 2 milliamps. And now we can start rewriting our circuit diagram. This is our new circuit diagram. Now we can find our current of Norton. When we do this, we can pick a node. I'll use this node right here. We can see that our 2 amps is flowing into it and our 3 milliamps is flowing out of it, and of course our Norton current is flowing out of it as well. So using Kirchhoff's current law, we can see that the current going in is negative, so we're going to have a negative 2 milliamps, and then our current going out is positive, so we'll have plus 3 milliamps plus our I of n, and this is all equal to 0. If we do this, we're going to get that our I of n is equal to a negative 1 milliamp. That is our I of n, as we can see here. But to check if this is actually the answer, we're going to rewrite this circuit one more time after we do one more thing, and that is combine these two resistors. Since they are in parallel, we can use the parallel formula for resistors in parallel. This is 1 divided by the first resistor plus 1 divided by the next resistor, all raised to the power of negative 1, and this will equal a 3.75. So now we can rewrite our circuit. And this is what we get. We can see that it's equivalent to the Norton circuit, so this is our answer. We have negative 1 milliamp and 3.75 kiloohms of resistance. If you want more introduction to circuit analysis problems, there's a playlist in the description below. If you want notes for this material, it is also in the description below. If you have any questions about the material covered, you can leave them in the comments and we will get back to them as soon as possible.